Welcome everyone to the talk that we'll be giving with Max DeMarcy today. For those who don't know me, my name is Christian Figueroa. I lead network science and behavioral modeling at Cash App. And with me is Max DeMarcy, my partner in crime, a graph engineer, and someone with a very nice haircut. That is a joke, and it stands for jokes that only I can make. Okay. Let's run through the agenda. I kind of hate this trend in recent movie trailers where the trailer spoils the movie. So I'm going to try to keep things very vague at this level. So roughly speaking, we'll start talking about customer behavior and why we care about that at Cash App. Then because we care about that at Cash App, we need to get metrics to measure customer behavior. The challenge we see with metrics that metrics are expensive to compute, especially graph metrics, really expensive. So for that, we need to solve it using graph algorithms that can help us measure the graph and measure our customer base. After that, I'll show you some results that we've had using graph algorithms to measure our graph. And then we'll talk about what's next. And better yet, Max will actually walk you through what is next. So if you want to think about it this way, we're going to talk about the goal, customer behavior, the problem, which is metrics are expensive, the solution, which is using graph algorithms, the results that we have, and the so what. Now, I'm a finance person. I'm a data scientist working in finance. So I'm going to start by giving you guys an overview of what Cash App is and how is it that we actually make money. So I'm going the opposite way. So let's start with that. Let's start talking about Cash App itself. So of course, that's the goal, understanding customer behavior. Of course, we don't have stores. We cannot see our customers. In fact, our platform is very interesting because customers don't transact. They don't interact directly with us. They transact with each other. So in a way, our platform is very social because it creates interaction between customers. And I love saying this, but what I find really interesting is that our platform is social because money is social, right? And the value of a dollar, a piece of money, a bill, is nothing if no one uses it. So in the same way as money is worthless if no one uses it, our platform is useless if no one uses it. So that observation is actually quite important because it means that the value of the whole system, the value of the whole company, increases the more people use it. And that observation is what motivates us to try to understand customer behavior. So that's our business, basically. Our business, we don't monetize from the transaction itself. We monetize from money that inflows into the system. And then when a customer either uses that balance to buy Bitcoin, to set up direct instant deposit, to swipe their card somewhere else, to pay with Cash App Pay, that's when we make money. So roughly speaking, this is a stats. We earned $17 for every monthly active customer in Q2 of 2023 alone. And just to give you another stat, another number, for every $100 that inflow into the platform, we make about roughly a little short of $1.50, so 1.5%, roughly speaking. Which means that the more money inflows into the system, the more value the platform creates for our customers, and the more we're able to monetize. That's the strategy part. That's the way that we see the business. But as you can imagine, this also it means that we start creating a graph as our customers transact with each other and they send money to one another. So every customer is a node, and every transaction forms an edge between two customers. And those edges can have different meaning depending on what relation that is. And those customers, because they're connected, there's a social link, they can influence each other's behavior. One of the important ones is their activity and how much money they influence the platform. If you imagine the journey of a dollar, it's really interesting to think about it this way. I like doing this exercise where if I send someone $1, then they send someone that money again, and the dollar moves like a random walk throughout the network, and eventually it leaves. And at some point, we monetize out of that, and we try to keep it in the network and keep it in the graph and track how it moves throughout the system. That's the main idea. And here, understanding customer behavior means that we want to map which nodes are most important. and which customers are facilitating money movements. That's the big picture idea. Now the problem is that graph metrics are really expensive to compute and really expensive to use. And I'm not saying that all metrics are expensive. Some metrics are actually really straightforward and easy. If I want to count how many connections you have, how many bidirectional connections, that's easy. But if you picture that dollar moving through the network, the further that dollar travels, the more I have to track it over time, and the more expensive that analytics become. So if I want to calculate, again, your friends, that's easy. Your friends of friends, that's more complicated, and that takes more time. In the graph world, that means traversing the graph. The longer that chain becomes, the more expensive and complicated things are. So that's the problem that we're trying to solve. Why do we care? Well, we know this. This is from literature in social sciences, that your friends, which are people that you have probably never met, influence your health, your smoking habit, your drinking habit, your happiness. They also probably influence things such as how much money you spend, what do you spend the money on, who do you transact with, whether you're active or not. And for us, activity of a customer in the app means more value because suddenly you can transact with them. And again, going back to the idea that if no one uses it, the app has no value. So that's how we create value. All right, let's get a little bit more specific about what we're trying to measure. So we're interested in, roughly speaking, 3 main things. The first one is node importance. You have to think about those central nodes in the graph as people that help create community. They create social value for the rest of the graph. So we're thinking about the religious leader. We're thinking about the local musician. We're thinking about the small business owner. And what is important about these people is that it's not just that they transact with a lot of people, but also that when they create an event, when they transact, those people also transact with each other. So again, it's not about the connections between, let's say, the musician and the audience. It's the connection that they help create and how they create a social value of the system. What is important here? Yeah, that's pretty much, yes. So that's the main idea. So we care about identifying these nodes, these important nodes, because they are the ones who help create value for the system. So by identifying them, we're able to better, market to them, better design products for them, and target them more efficiently. That's the main idea. And we'll talk about it later, but I just want to give you like a heads up that the way that we measure this doesn't have to do with just the relationship that they have with their customers. It has to do with the relationship that their customers have with each other and the relationship that they have with someone else. So just as a thought exercise, think about it, the local coffee shop that you always go to. What happens if they close down? There's a place that you don't go anymore, a place that you don't interact with people anymore, and those spillover effects that maybe other places in the area might benefit from, they disappear. The next one is thinking about now group importance, thinking about identifying communities and clusters of different nodes. This matters a lot for us because it helps us segment our customer base into different groups. And we realize that different groups have different needs and different needs for different products and different ways of thinking, which affects the way that we position our brand with different customer groups. So by segmenting, we can set segmented and targeted goals for different groups of customers. So what might work for one group might not work for the other, and identifying these communities is really crucial for that. The last thing is thinking about shape importance. And this is what I was trying to explain when I was giving the example of the musician that creates community, is that you can think about different structures of the graph, and they all mean different things. So on the left, you have a lot of transfer within the group. So you have certain nodes that are important because they create community, and certain nodes that are important because they turn into middlemen. They help move money from one side to the next. And we're trying to identify these patterns that we see in our graph. So that's the broad idea. That's the solution that we want to tackle. Well, how do we find these things? How do we find what nodes are important? How do we find these clusters? How do we find these patterns in the graph? The solution, of course, graph algorithms. There are ways of solving this that turned out that they're very computationally expensive. So ideally, what we would like to do, someone like me from finance and strategy, I would like to be able to write SQL, and I would like to be able to say select star from graph. That would be great. But well, it's not easy to write that kind of queries. If you start doing it with the old-fashioned way of rows and columns, you start joining a lot, and you think about traversing the graph like that. It's not efficient. So maybe some stored procedures. Well, we require both expert graph algorithms, implementation, and a lot of SQL knowledge to write those queries to begin with. And then performance, right? Like this doesn't really scale. We've tried it. It doesn't work very well. Then we started evaluating certain alternatives outside of Snowflake, maybe some more powerful general purpose computing tools. And I gotta be honest, it wasn't that great. We tried throwing a lot of compute power to it. And it was, I wouldn't call it a disaster, but the algorithms did take a very long time. And a very long time for us means the difference between I am going to set it overnight and look at the results tomorrow, so I cannot make the decision today, versus I'm gonna wait 10 minutes and see what the results look like. And once I can see that, I can make much better informed and faster decisions. So we tried a few things. They took a lot of time. Some of the algorithms that were more specific for our use case were not even available. And again, like this is for the more non-technical people, right? Thinking about why these algorithms take so much time, and this idea of traversing through the graph. Imagine a table with 50 million customers, each with just 10 friends. And that's very common in our graph. We have 57 million transactive active, so these numbers are actually fairly reasonable. Each one of them will transact with a certain number of customers a month. And just think about joining that table to itself 3 times. That doesn't scale, right? That's a big, massive table, and then you have to join it aggregated. And it also has the issue that if you don't exactly know how to build the graph, because there are different ways of calculating the graph, different ways of building the edges, different ways of measuring the graph, then you can't experiment. You can't iterate. You can't tell your manager and say, hey, I think this is the right concept of centrality. I think this metric of centrality is capturing the priest, the pastor, and this other metric is capturing the local musician. So that's when we started working with Max and his team at Relational AI, because they came to us and they said, well, we have a solution where your data can stay in Snowflake, and you can actually compute graph analytics and all this. You can experiment with all these different metrics and build these different graphs that you're thinking about without leaving Snowflake. So there wasn't really an expensive ETL to build or maintain, because our data is there, and they just put their graph relations on top of that. So then you run algorithms on top of the relations and not on top of your raw data. And that is much faster, much more efficient, or so they said. So we actually tried it out, and the results were actually pretty interesting. So this is what Max will talk about it a bit more later, but roughly speaking, these are some of their offerings. And what we were interested in was this on-demand graph analytics. We wanted to be able to select star from graph, basically. So we started this journey with them, and we started first defining our graph. And as I mentioned before, there are different ways of doing this. So it was very clear that our relationships, those transfers of money, are signal a relationship. But it wasn't clear it wasn't clear how to separate the difference between paying a merchant for something, sending a tip to someone, or sending money to a family member that might be sick, or splitting the bill with someone that you just went to get coffee with for the first time in years. And we started building the graph in different ways. And one of the advantages that we saw of working with relational AI was that, well, we can try all of these ways, and then we can kind of like see what the results are. And we can, and because we're in strategy, we can look at the numbers and see, well, do they make sense? Do they align with the way that we think about the business? More specifically, there were 2 algorithms that we were very interested in. One was eigenvector centrality. And eigenvector centrality is, from the graph world, is the way that we operationalize the concept of centrality. There are other ways of doing it. This one in particular measures node importance. And the idea is actually quite simple. The math is complicated, but the idea is simple. The idea is that I'm going to define a node to be central when they're connected to a lot of central nodes. And you're like, well, that definition is kind of recursive. But it turns out that you can actually solve that. It's called an eigenvector. If you know matrices, that's exactly what it is. It's easier said than done, though, because it takes a lot of time to compute. Because if you imagine this as computing it iteratively, I'm saying the importance of a node is determined by the importance of their neighbors. And the importance of their neighbors is determined by the importance of their neighbors. And then the importance of those neighbors is determined by the importance of those neighbors. So we're already at the example that we're traversing the whole graph. And that's something that we were not able to do with the tools that we had at hand, but we were able to do it with the pilot that we had with relational AI very quickly. The other algorithm that I'm going to go back to the idea of this dollar moving through the network. So it's an algorithm called InfoMap. And the idea is that if you imagine a dollar, right? Like you go to get coffee with a friend, you send them money. Then they use that money to go down the street, and they pay for something to the merchant. The merchant goes and they pay their provider. Their provider maybe is a friend of yours, and then the money comes back to you. And then you use the same dollar to pay someone else for another service. And then that dollar moves around the graph. And you're like, well, this dollar will get stuck in certain places at some point. There are certain groups of customers that are so connected that money won't leave that place. And then eventually it jumps to another place, because maybe you travel to another city, and then you pay someone there, and then the node gets stuck in their community. And the InfoMap algorithm is something that we wanted to implement for a while. We wanted to look at those results. But it is very difficult to compute and very expensive because you're traversing the whole graph multiple times. So it is a random walk of a dollar through the graph. Roughly speaking, and the reason why this slide has a map is because what we're doing is we're trying to find the neighborhoods of different groups of customers and trying to identify those pockets of places where money stays stuck, because we think that those are very interconnected. And when we can set targeted goals for them, those goals are going to be different for different neighborhoods. I'm going to talk very broadly about the results because I can't share too much. But very broadly, the main outcome of this is we're starting to see graph thinking within our company. We're starting to develop a shared language around networks. And when our analysts are thinking about centrality of the nodes, and they start thinking about designing products for those central nodes, that's when we say we're achieving our goals. Because in the end, if you think about the central nodes, for example, they are the ones who create value for the rest of the graph. So if we can better identify them, we can better serve them, and we can better serve them and design products for them, we can measure them now. We can track them, who they are. So more specifically, cost savings, of course we did this. We're moving away from some legacy systems into this more efficient way of doing things. We're already seeing that. Targeting, which is the connection with central nodes. We can target our most important customers. And the way we do it is that we're just starting to define KPIs at the level of the central node and say, okay, we're going to target the central node. So like now products that are designed, one of the outcomes that they can target is we're increasing the centrality of central nodes, or we're increasing the number of central nodes in the graph. Focus, the fact that we're better able to divert resources into different communities because we know who they are and where they are. So we can say this community, they care a lot about our banking products. We know that they're very interconnected, but they care about banking. This community over here, well, this community is around a school, so maybe they care about some of our family's product. And we can start marketing more effectively and more efficiently, and building and designing products more efficiently, because then we can say we want to survey this group of people to try to understand what exactly is it that they are interested in. But we know that they're a cohesive and connected community. That's the more soft way of thinking about it, if you want to call it like that. We are nurturing the network. We're growing this network because we believe that that's the value of our company. So the healthier this network becomes, the more value we can create, and the more value we can capture for us. So what's next? What's next? You're next. But I guess not you, but you're next, right?
I'm next.
You're next. Great. Right, I'll leave you guys with Max.
Now, actually, this slide is correct. I'm not next, you're next. What are you going to do with this knowledge that you're here to learn today, right? Because you're not here just to find out what Cash is up to. You're trying to find out what you can do back home for your business, for your enterprise, and take away something that will help you there. So you need to start thinking about your data. Start thinking about whether it looks, smells, or tastes like a graph. Or could it be a graph if you just look at it sideways and wink a couple times? Could it be one? And probably there is. I think in every enterprise where you have at least customers or you have things that are heavily related, you'll find these pockets of graphs that you can use graph analytics on to understand what's really happening there. And what kind of graph do you have, right? Do you have a very complex graph that has a lot of different types of nodes, has a lot of different types of relationships? Do they follow a direction, like on Twitter where you follow someone but they don't have to follow you back? Or something more like LinkedIn or like Facebook where you kind of have to both decide to connect with each other, right? So the direction is not really known, it doesn't really matter. And then how strongly related are these relationships? How strongly connected are they? Is this somebody who was a friend 20 years ago that you met in grade school that you've kept up with for 20 years and they love you to death and you babysit each other's kids and dogs? Or is this someone you just met 5 minutes ago who you just barely know because you went to the same conference together? Right? These kind of relationships and weights matter. So why? Why graph analytics? What capabilities do they bring to the table that you don't really get with your standard complex analytics that you might get out of Snowflake directly, right? You have to think about what questions you're trying to answer from your data. What questions have you not even thought about asking your data because you thought, oh, it's going to be too hard to compute. It's going to be too hard to do. I don't really want to stress out and pay for a giant bill because I don't know what's going to happen. Maybe you're looking for something like the best routes between 2 points. Maybe you're working supply chain and you're trying to optimize those kind of queries. Maybe you're trying to find, like Cash App was or is, the most influential nodes in your network. Who are the customers that help move the needle one way or the other, or whose reviews or whose product recommendations influence the market in general, and you can take advantage of that. Or your critics, who are your customers that hate you, and how can you ask them to pipe down or silence them, or just please them in some way to make them happy customers again, if you take the happy route. Maybe you have a bunch of products that you sell, and you want to figure out what other products are similar to those products. Maybe I can reuse the reviews from a previous product, or say this car part now fits a bunch of other cars that we didn't know it could, but it's similar enough in shape and size and form that we can do that with. Or this product is too expensive, there's a new one in the market that's 20% cheaper that has the same functionality. We recommend that to some of our lower spending customers. And then look for things like suspicious patterns of behavior. Most of your users will behave a certain way, maybe a couple of different modalities, but you also find these pockets of behavior that doesn't make any sense. You're like, how does this person watch 5,000 movies and rate them all 5.0s, right? That doesn't make any sense. And then look for things like missing links. Where are there relationships, and where are there missing relationships in your data? You can get all that with graph analytics. So node importance. We already talked about understanding customers who build social communities as one reason why you may want to find node importance. But there's more than that, right? Depending on which field you work on. Let's say you happen to work in the security field. You want to know who to investigate, who is central to a criminal organization or potentially criminal organization. Or maybe it's backwards. Who you want to protect from getting into trouble or having some accident happening to them that shouldn't have happened to them. Or maybe you want to just spread information around or misinformation around. Where do you want to plant that information? Who do you want to talk to? Maybe you work in public health, and your job is to help people not get sick. So who do you immunize? Who do you quarantine? Where are the people that move diseases from one community to another, especially in a place like San Francisco? Who do you track to explain that disease, that spread, right? And who is most at risk? Is it just elderly? Is it young kids? Is it people who just refuse to be vaccinated? Like, what is going on? How do you identify these folks, and how do you help them? If you happen to be in management, who do you want to get on board if you want to make a major change, right? Who are the important nodes in your actual enterprise? It's not always the people at the top. It's sometimes people in the middle who are the decision makers, ultimately, oddly enough. And then which of your employees are super important that you don't want to lose to your competitors, right? Who are the ones that kind of hold the ship together, and if you lost them, then it's going to be very painful to replace them, right? And then vice versa, who do you hire away from your competitors, right? Now that you don't have to worry about NDAs and non-competes, it's time to go find the best people wherever they may be and bring them over. And then in marketing, once again, who to ignore, who to empower, who are your influencers, and how can you make them do their job even better? And it goes back to the question is, what do you want to do with your data, right? Maybe you just want to find some statistics about your graph, just to understand like what's happening, how connected are our nodes, what are they doing, how many relationships do they hold, how many neighbors do they have that are coming in or that are going out, and they mean two different things. And sometimes it's not just one metric that matters, but the ratios of metrics, like how many transactions do they give out, but how few do they take in? Maybe that means something important to you. You want to figure that out. Also things like reachability and how do I get there? What kind of paths do exist? One example use case is if you happen to work in the health field, you look at a patient and you say, a patient comes to a doctor that has a requirement for some symptoms. So they, I'm feeling bad, I have this problem, I have that problem. We're going to treat your symptoms over 3 to 4 months. We're going to give you all these tests. We're going to prescribe these drugs. We're going to give you these operations. And at the end of that, hopefully, you live and you're healthier and everything is great. And then the next person comes along with the same symptoms, and we track their path through the system. And we do this over and over again, and we have 1,000 people going through with a similar starting point and different ending points, different times, different costs. Maybe you find procedures that were unnecessary or drugs that were not very effective, and you say, well, let's cut that out. Let's not give them that. Or it'd be better if we did something else, right? So you can look at individual paths on top of each other, build a graph, and build something intelligent from it. Centrality, we've talked about already quite a bit, and there's many kinds of centrality that matters. Some people have so many friends, they're really important. Other people, they bridge communities. And if you lose those people, then two communities can no longer talk to each other, and that may be a problem for what you're trying to build. There's, I want to say, dozens of different centrality measures, and they all might mean something different depending on what you're trying to do. Also similarity, this is where graphs are used to build recommendations. Customers that are similar to each other, products that are similar to each other. You can find things like car similarity and cousin similarity and another dozen or so similarity metrics to help you understand how things are related and why you may want to recommend one thing over the next. And then communities. Detecting your user groups, figuring out what they do, figuring out where they are, how can you target them. If you ever use Netflix, after a while you'll notice that it starts giving you these 3 tag category recommendations, right? So you may like romantic comedies about zombies, and that happens to be like one of the things you're into. Now you'll recommend 5 romantic comedies about zombies that you can watch, because you figured out that that's your thing. So figuring out what your customer's thing is and then being able to micro-target them or niche target them is very important if you want to increase your revenue there. And then link prediction, which is the easiest one to think about, is we're missing links here. How do we recommend a new link? And what does a new link mean? It could be someone who you should meet. It could be another order, another product that you should buy, another action that you should take on your way to ordering a product, many kind of different things. And if that's overwhelming, then think of it the simplest way, right? Graphs are really good at 2 things: finding relationships that should exist but currently do not exist, and then finding relationships that should not exist but currently do. And that's the way to think about recommendations and about fraud. In recommendations, you're looking for those missing relationships that should be there, and everything is telling you that that should happen. And then in fraud, it's the opposite. You have people who are sharing social security number or some kind of ID or an old address, an old phone number, synthetic identities being created at banks, all kinds of reasons why these relationships should not exist. Let's go find them and track them down. Now, how do we do this? I'll show you an example of how it all works and how easy it is to use. So hopefully those in the back can still read this. Once you install the relational AI native application, you'll be able to import some of our libraries. They'll give you access to the graphs and to connecting to Snowflake. You are going to create a model, which is kind of like a schema in Snowflake parlance, right? With your model, you're going to tell it which pieces of data in Snowflake you want to use to build this graph. You already have your data is existing. Figure out which tables or which views represent nodes, which tables or views represent relationships, and then tell me more about them. Describe what they are, right? In this case, we have a people table that becomes our person. We have a friends table that's going to become our relationships, our friend relationships. We're going to describe the foreign keys, if you will, in this table, person 1 and person 2. Then we're going to say, all right, from these 2 tables, I'm going to create an edge. That's going to be my friend edge, and it's going to connect people to each other based on their foreign keys. Now that I have this data described and these tables described, I'm going to go ahead and create a graph. I'm going to say, I'm going to take my model, build a graph. It's going to be undirected in this case. And I'm going to add the friends edge. Now, dynamically, you can make a really simple graph that has just this, or you can make a very complex graph that has 50 different tables, different kinds of edges, different kinds of nodes, and just add them all in if you like. Or you can just keep it simple, like in this case. Once you have your graph built, then you can start running algorithms on it. So this is how you would run PageRank on it. And then you'd say, all right, take the score of PageRank, take that customer's name, and spit it out somewhere in our results. And we're going to take that results table and put it back in Snowflake, so then we can do something with it, pass it on to another model or whatever it is you're using with it. That's how easy it should be. You don't have to learn a new language. You don't have to learn Cypher or Sparkle or Gremlin or some other crazy thing. You just use Python, which most of you developers hopefully are familiar. You just got to learn our API a little bit, and you're there. Now, there's one more thing I got to tell you, and that is that we are a knowledge graph, right? There's a lot more to relational AI than just graph analytics. We're basically just showing you a small fraction of our capabilities, right? Because we're not a relational database. We're not a graph database either. Some people might be confused by that. We're a knowledge graph. And you're like, OK, well, what's the difference? Well, relational databases know nothing, right? They're like that character, Jon Snow, in Game of Thrones. They have absolutely no idea what's going on, right? Where did this foreign key go? Why are some of these rows empty? What do all these numbers mean? They're just numbers. I have no idea what's going on, right? You have to tell it what things are based on your queries. Your SQL queries give it intelligence. Otherwise, it's just a bunch of numbers sitting on a table somewhere. You have to be the intelligence. Graph databases said, hold on a second. We're going to make data smarter. We are going to tell data how they're connected. They know who their neighbors are, right? So you can ask every node, hey, who are you connected to? How many friends do you have? And it can tell you that, right? It understands relationships. And you get a lot of power from that. That's all it knows. All it knows is, I got neighbors, and I can tell you who they are. Knowledge graphs, they know everything. They do. They know everything you're willing to teach it, right? What kind of node is it? What properties can it have? How is it allowed to connect to other nodes? What rules does it have to follow? How does it fit into the model of your world, right? How does it affect your business? And with knowledge graphs, you can teach your data about your application logic. Everything that you spend your time doing in C++ or C# or Python or JavaScript in your dozens of applications can all go into the knowledge graph and just be done once instead of over and over and over again. So we can make your data intelligent. And you may be thinking, OK, but why? Why would I want to do this? Why would I make the data intelligent? What do I get out of it, right? Well, you're going to learn something, and your data is going to learn something. Think about a transaction, and think about asking the transaction, are you fraudulent? It's a really simple question. Are you fraudulent? And it responds, I'm 53% sure that I am fraudulent. You're like, oh, crap, 53%. That's like a coin flip. I don't know if it's fraudulent or not. So what do? Do I reject the transaction, or do I take the risk that it's going to be OK? I don't know what to do. But your developers, your data scientists, your engineers, they get better at finding fraud. They get better at understanding these patterns. And they teach the knowledge graph how to do that, right? And then your application asks, again, that same transaction, are you fraudulent? A really simple question. And this time it responds, I'm 89% sure I'm fraudulent. You're like, all right, you know what? Close enough. I'm going to reject that transaction. It's no good. Right? And you may have one application. You may have 10 applications. You may have a dozen data scientists. You may have hundreds of business users asking simple questions. They're all going to benefit from this learning. Right? Everyone benefits from bringing intelligence to the data. 5 minutes ago, you thought relational AI does graph analytics. Now you know relational AI does graph analytics and a whole lot more. And if you want to learn more, go to our website at relational.ai or ask your Snowflake partner about us. And with that, thank you. And we have a few minutes for questions. Any questions about the use case or relational AI or graphs in general? We're happy to take. Yes, sir.
Question for Christian. You talked a little bit about metrics, right? You talked about the centrality of nodes and that those potentially KPI. What about the dollar value of
Yeah, that's a really good question. We're actually leaving it mainly at this stage to the product teams, mainly because we just started working on this. So if I can get a product manager to tell me this product is, we're going to greenlight this product because it will increase value for central nodes, that's a win. That's what we care about. Now I'll leave it up to them how to define the trade-offs between this product, this feature, or other features that they might be thinking about. Does that make sense?
It does. But like, let's say in 2 years, what do you expect to be measuring then relative to what you're measuring now in terms of the success and value of these graphs?
I don't have a good answer for you. Yeah, that's a really good question, though. Yeah, for sure. No good answer, sorry.
Other questions? Yes, sir.
Probably requires a little more in-depth chat, but is there like a health metric for a network? And I guess it really depends on the use case and everything like that. But for example, at Canva, if we sign up an enterprise account and they're all collaborating, using it, and stuff like that, is there a health metric that would you recommend or would make sense?
So there's no one health metric. That's the problem, right? So you have to understand what actions you want your users to do, then what those metrics represent to be able to find those actions, and then how to grow those metrics, right? In a lot of cases, you want lots of interactivity between users. Sometimes maybe you want that activity to grow or just remain steady, and you measure it over time. And as long as it's steady and not declining, you're fine. Sometimes it's different paths through the graph that people take, different actions that they take, and if those paths are getting shorter, then that may be a benefit to you because they're getting their work done faster. If the paths are getting longer, maybe you have too many clicks that they have to go through in order to get the result. Or maybe it means that they're spending more time in the application, which is actually what you do want. So it just depends on what you're trying to do and how it relates to your business. The answer to that is you have to experiment. Try a lot of different things, see which ones move up and down, track it over time, and then cull it down to the ones that really do move the needle back and forth, right, in your business. Yeah. When we can help you, we can point you in the right direction in a lot of cases, but you need that particular business enterprise knowledge to pick the right ones. Yep. Anything else? Going once? No? All right, thank you very much. Appreciate you all coming out.
Thank you all.